Alright guys, last portion to learning target 3, and this is a factored form that we're going to be learning about today. Little review from the previous forms. Our vertex form was y equals a x minus h squared plus k. Standard form was y equals ax squared plus bx plus c. Now our factored form is y equals a x minus m, x minus n, okay? Some key characteristics of graphs in this form. X-intercepts are m and n values, okay? So these are our x-intercepts. To find the vertex, what you have to do, you need to find your x first, which is m plus n divided by 2. Okay, and then once you find your x, you're going to substitute x into the equation to solve for your y value. Now your axis of symmetry is the same thing as your vertex here. It's going to be x equals m plus n divided by 2. Our domain again is negative infinity to positive infinity. Range, if a is less than 0 and it opens down, okay, it's going to be negative infinity to the y value in our vertex again. Bracket, so it's going to look like an N shape. If a is greater than 0, it opens up. So that means we're going to start with our y value vertex to go to infinity, parentheses, and that goes up looking like a U. All right, procedure for graphing functions in this form. Identify the x-intercepts. Find the value of the vertex by adding the x-intercepts together and dividing by 2. Then substitute that number in to get the y value of the vertex. Plot these 3 points and draw a smooth curve. Okay, so we're going to practice that now. For example 1, let's identify what our x-intercepts are. Okay, so x-intercept here, x-intercept here. So our x-intercepts are 3 and negative 1. We're always flipping the signs, okay? So it's a negative 3 here, so our x-intercept is a positive 3. And that would be because if we took it x minus 3 and set it equal to 0 and solve for x, I need to add 3 to both sides. So x equals a positive 3. So we're just going to go ahead and flip the sign, and that will be our x-intercepts. Okay, so you can go ahead and graph that. We have x-intercept at 3. And we have an x-intercept at negative 1. So that's just where that crosses the x-axis. So there is a point there. Okay, so for 2, we're going to find our vertex. Okay, we're going to take our m and our n. So x equals 3 plus a negative 1 and divide by 2. So 3 plus negative 1 is 2. Divided by 2 equals 1. Okay. Then we are going to take that and plug it in. So take our x value and plug it into the equation to find our y value. So y equals 2 times x1 minus 3, parentheses, 1 plus 1. Okay, so all I did was took this x value for my vertex and plugged it in to the equation. That's how I got this right here. Okay, so now let's simplify it. Let's do inside the parentheses first. We get 1 minus 3, which gives me negative 2, and 1 plus 1, which gives me a positive 2. So 2 times negative 2 gives me a negative 4, carrying down that 2, and then negative 4 times 2 gives me a negative 8. So my vertex is 1, -8. So I can graph that point. We're going to make that smooth curve. How do I know that it's opening up? Well, because my A value is greater than 1. All right, moving on to example 2. Our n value, x-intercepts. So our x-intercepts are, just make sure you switch those signs. X-intercepts are going to be a +6 and a +4. Now we're going to take our x-intercepts and try to find our vertex. So 6 plus 4 divided by 2. 6 plus 4 is 10 divided by 2. 10 divided by 2 is 5. I'm going to take my 5, x equals 5, okay, and plug it into my equation. So y equals 1/2 times 5 minus 6. 5 minus 4, so 5 minus 6 is -1. And 5 minus 4 is 1. So 1/2 times -1 gives me a -1/2. And -1/2 times 1 gives me -1/2. So our vertex point is 5, -1/2. Okay, so we're going to plot all those. Let's go ahead and plot our x-intercepts. So I'm going to plot these first, 6 and 4. 4. Plot that right there. Then I'm going to go ahead and plot my vertex. So 5 1/2, so 5 1/2 right there. Okay, we can just make our smooth curve here. There you go. Let's go ahead and move on to example 3. Okay, example 3. My n value, x-intercepts are the opposite of signs of my m and n. So -3 and a +4. I'm going to take those and plug them in to find my vertex points. So -3 plus 4 divided by 2. -3 plus 4 is 1 divided by 2. Just gives me 1/2. I'm going to take that, plug it in for x into my equation. So y equals -1/2 plus 3. 1/2 minus 4. Let's go ahead and combine. So 1/2 plus 3 gives me 3 1/2, or you can just write it as 3.5. We'll just write it as 3.5 right now. We'll take 1/2 minus 4, so that's also going to give me -3.5. And then you'll need to multiply 3.5 times 3.5. 3.5 as a fraction is 7/2. Okay, so if you want to multiply them as fractions, so I'm just going to write them as fractions here so it's easier to see. So because they have a common denominator, I can multiply straight across. So 7 times 7 gives me 49. 2 times 2 is 4. Don't forget about the negative. So that reduces to 12 1/4. Okay, so 12.25. So my vertex point is going to be 1/2, and let's just say 12.25. So we'll go ahead and do that. So it would be, I'm actually going to change my 1/2 and make it a 0.5. So half and then 12.25. So about right here. All right, now I'm going to graph my x-intercept. So -3 and 4. Now we're going to connect the dots and make it a smooth circle. Not very good. Should look more like a N, but that's just a bad one. There you have example 3 graphed. Moving on to graphing example 5. Step 1, let's find our x-intercepts, which are -1 and a +5. We're going to find our x value. So -1 plus 5 divided by 2. -1 plus 5 is 4 divided by 2. 4 divided by 2 is 2. Now we're going to take that and plug it into our equation. So y equals -3. Plug it in our x, 2 plus 1. Plug it in x again, 2 minus 5. Let's simplify. Carry down the -3. 2 plus 1 is 3. 2 minus 5 is going to give me a -3. So -3 times 3 gives me a -9. Multiply that by -3. That is going to give me a +27. So my vertex point is going to be 227. Okay. And my x-intercepts are -1, 5. I'm going to go ahead and graph those. Okay, so obviously this graph isn't big enough for our vertex point. So let's go ahead and count on the y-axis by 3s. Okay, so 3, 6, 9, 12, 15, 18, 21, 24, 27. Okay, and we go on, so on, and so on. So my point is 227. So it would be right there. We'll go ahead and connect those. I know it's going down because my A value is negative, okay, which means this is a maximum point. All right, moving on to example 5. Example 5, identify the vertex axis of symmetry, whether there's a maximum or minimum, domain, and range of the equation, y equals -2, x minus 4, and x minus 6. So I'm just going to do this first because I think it's the easiest thing. Deciding if it's a maximum minimum. If the a value is negative, that tells me right away that it is a maximum. Okay, because since it's negative, it's opening down, so it looks like an N. So our vertex point is a maximum because it's the highest point. All right, let's go ahead and start by identifying our x-intercepts so we can find our vertex. So here's M, here's N. So our x-intercepts are 4 and 6. To find our vertex, I'm going to take 4 plus 6 to find the x value of our vertex. 4 plus 6 divided by 2. So 10 divided by 2, which gives me 5. I'm going to take that and plug it into the equation to find my y value of my vertex. 5 minus 4, 5 minus 6. So 5 minus 4 is 1, 5 minus 6 is -1. -2 times 1 is -2. And then -2 times -1 is a +2. So my vertex point is 5, 2. So my axis of symmetry then is going to be the same thing as what my x value is in my vertex. So axis of symmetry, x equals 5. So we've done that's good to go. Now our domain, -infinity to infinity. Range Using our y value, first we need to determine if our a value is less than 0 or greater than 0. In this case, it is less than 0. It's a -2, so it's going to open down. So we're starting with the negative, and we're going to our y value in our vertex right here, so 2 with a bracket. That is how you figure out example number 5. If you have any questions, make sure you're jumping on the Google Meet. Otherwise, have a great day.